Hi everybody, welcome to this tutorial of how to look through a nested dictionary with Python. Let's begin talking a bit about dictionaries. Dictionaries in Python are a built-in data structure, more technically a built-in data type, very similar to real-life dictionaries. The data is arranged in the key-value form as in dictionary, where a word could be the key and its meaning would be the value. Here we show a way to define a little Python dictionary called D. The dictionary keys can be several types of data, but not the list or a dictionary itself as they are mutable. Instead, the dictionary values can be list or even another dictionary. This last case is what we call a nested dictionary. As we can see in this example, the key name has a dictionary as value. A nested dictionary, as we see, could be a good option when we have to store data in a structured way. Sometimes we may need to go through all the values in a dictionary even if they are nested as Mary and Smith. Here we're going to see some methods to do it, and we're going to show it by printing each key value. As an example, let's use a simple data structure that simulates the data of a programming course for children. Here we have some data as the title, the structure, students, quality, and this structure can be written in Python as you see here. The key students have as a value a nested dictionary with the students number 1, the student number 2, the student number 3. For example, the student number 1 have inside another dictionary with the names and his age. We have in this case 1, 2, and 3 nested dictionaries, and we save this structure in the variable course. One way to see that it is a dictionary is, for example, print type course, and then we can print course. If we run, and we have this result. As we see, the type is dict. Let's go to the first method. Recursion is a form to go through all branches and sub-branches and sub-sub-branches of a tree data structure like we have here. The main idea in this method is to get each pair of key value from the dictionary, as in this case. And if it is a dictionary, like in this case, you call again the function with the value as the argument. This is recursion until the value is not a dictionary, like name and Mary. In this case, we just print name and Mary. Let's implement this in Python. First, the function did walk with the argument d. Then we use the for to iterate over the list which contain the dictionary's elements. For key, the key and value in the items returns a list with the elements, with all the elements of the dictionary d. Now we evaluate if the type dict. We call recursively the function. What v is the argument, and before this I would like to print the key. Print key. This is the key that corresponds to the value that is a dictionary. Else, print the pair key value. And then I have to call the function. Now we can run. Before we have to delete the parentheses. And this is the output of the program. We see in this case title is the key and programming for children is the value. But in the next instructor is the key and have a dictionary inside with the name and the mail of the instructor, and so on. Here we can use another function also. If its instance is the it is another way to get the same result as we see here. Its instance is more general. The difference is that type works only with Python built-in data types. We can use also dictionary comprehension. The pair we will get is the key and the value, but if the value is a dictionary, we call recursively the function. If is instance else we print key value p for key and value in the items. Well, I have an error and here, and that's all. When I run this, I have this output. As you see, this program doesn't bring the nested key as before, when we bring instructor, when we bring students, and 1 and 2, and so on. And for this reason, this program is faster than the previous one. But what happens if you want the same output of the first one? It's simple, free. In this case, we use a similar but different strategy. I mean, it is a dictionary comprehension, but in a different manner. So I copy this, print if. In this case, I will use not equal and type function. Type the not equal date. And inside else, I have to run these two lines. I can put these two lines in one line with the exact function. Exact copy. Paste here and use this to tell Python that this line is below to this line, and then for exact I have okay, and that's all. I have an error here. We need this. And now we can run the program. And as you see, we have the nested key as instructor, as students, and 1 and 2, and so on. I made a testing dictionary with 10,000 entries, and in each entry we have a random number of nests. With this testing dictionary, the example 3 is the slowest. Well, let's go to the second method. In this case, we iterate over a list that works as a stack. But what is a stack? It's a way to manage set of data that can be very useful in some cases. The characteristic of a stack is that the last element that enters is the first that leaves. We can symbolize this with the very well-known acronym LIFFO. Last in, first out. The main idea here is use pop function that extracts the last pair of the stack, for example this, and then if the type of is dict, In the case it is true, I use the extend method to put each element in the stack, and then we begin the loop again. And in the case the value is not a dictionary, we print the pair key value. And when the stack is empty, the while loop finishes. Let's implement this in Python. And this is example 4, the same function name, and the first is save in a variable stack the list the items with all the elements of the dictionary. We use while stack to iterate over the list until the stack is empty. Then I extract the key and the value with stack pop. As we said before, this extract the last pair. Then the if, and if this is true, stack extend. We extend the items inside the value. So we extend the stack with these elements. Else print b. And we can run this calling the function. And this is the output. As we see, this method goes backward. To go from the beginning to the end, we would have to extend and extract at the beginning of the list. But doing this with a list is not efficient. So finally, this method does not print the nested key as students, as instructor, and this is another difference with the method 1. Let's go to this new part of the video in which we are going to see a new method, method number 3, that implements a generator. In easy word, this method consists of making a generator that returns one dictionary element at a time. If in this element the value is a dictionary, we apply recursion until the value isn't a dictionary. This is the process we tried to show in this figure, and is similar in a certain way to what we have seen in method 1. A generator works similar to a function, but instead of using return, it uses yield. But what does yield mean? This means that each time the generator is called, it returns what is under the first yield. For example, the first time I call function 1, the result is 1, because the first yield returns 1. The second time, return 2, and the next time, return 3. The difference between yield and return is that yield returns something but does not continue the process until the generator is called again. And when it is called again, it can continue from where it was last time, because the state, for example the value of the local variables, is saved. In this case, in addition, if the value is a dictionary, the generator calls itself recursively until it finds something that is not a value. The fact that a hand generator works element by element implies normally memory saving. So let's go to Python, and as you see, I just put the first part of the example 1 because it is the same. If the value is dict, we have to call recursively the dict while generator with yield from statement. Yield from dict walk b. This means that if b is a dict, yield from send b to the generator itself. Else yield k value. And now Walk in this case is like a function, but it's not a function, it's a generator. So I can iterate over this generator with for in the walk the print okay. We had to use source here, and I run first this code, and then and before I run this code, I would like to yield key, where key is all the nested keys. Now we can run this code, and the output, as you see, has the nested case as instructor, students, and one, and so on. Another possibility that is more general than this one is, instead of test if B is a dict, we can test if B is ABC mutable map, and then all is the same as in this example. But what is ABC mutable mapping? ABC means abstract base class, and can be used to test whether a class or instance provides a particular interface. For example, if it is a mapping. A valent Python dictionary corresponds to the ABC class called mutable mapping, which in turn is a subclass of mapping. This allows us to check if something is a dictionary. In addition, mutual mapping and more generally mapping allow us to work with other classes that work like a dictionary. We can implement this way in the other methods as well, but we are going to show only in this one. And finally, in this case, we have to use is instance instead of type, because type works only with built-in Python data types like dict or list, for example. Let's go to Python. This example is like the example number 5, similar, but we had to change its instance ABC mutable mapping. And first we have to import ABC from collection, import ABC. The difference between example 5 and 6 is that example 6 is more general. You can work with a custom data type that could be similar but not exactly a dictionary. If we run this code, I have an error here. So now I can run again, and as you see, it's the same output as in example 5. I would like to talk about an additional tip. This is a little variant that can work with many of the above methods. We use items in all of the methods we saw. Items returns a view object that provides a dynamic view of the dictionary entries, which means that when dictionary changes, the view reflects these changes. Perhaps it is not necessary in the program, and we can iterate directly over the dictionary, as we will see in this example. Sorry, I moved because a disturbing noise from the street. The first thing is copy example 1, and then delete items, and here k represents the key, and we get the value the key, and that's all. If we run this program, we have the same result. This is another simple way to do this, and using these iterations have similar performance in my test. As a conclusion, after testing the examples with 10,000 entries dictionary, nested dictionary, I have to say that the highest memory peak is similar in method 1 and 3, but method 2 is almost the double. And in the speed, method 1 and 2 are more similar, but method 3 was always above 30% slower. And for all this, if I had to choose, I would start by trying method 1. Thanks for watching.